this short lecture, we're going to do another class, and again, I'm going to show you this interplay between multiple classes, or how we use one class to build up more complex interactions between objects. So let's go ahead and start by defining a very simple class called the tree class. This class has two functions, of course, a constructor, because every class has to have a constructor, and a simple drawing function. So let's start with the tree class. As you might imagine, this tree class is going to specify a tree given a location on the canvas, and then draw that tree. So the location is simply specified using XY coordinates. The size of all the trees will be the same, the colors will be the same. Obviously, I could have changed that. I could have had the tree class specify a size and a color and a location, but for simplicity, we'll just do these two. So two parameters come in, and I'm going to assign those parameters associated with the object to be the parameters that are passed in. The draw function is relatively straightforward. It's going to draw a tree having two components. The base, or the trunk, which is this rectangle here, and the top, which is the circle. The base will be in brown, the top will be in green, and notice here that I'm specifying, so remember again, I have the position of the tree at XY. That will be the circle, which will be the top green part, which I'll show you in a minute, will be at location XY. That's the point of the tree, and it will have a radius of 12, and it'll have a color of green. The slash, again, is just because I have a line wrap here. The base is at x minus 4 and y minus 35. So what that does is it slides it over a little bit, comes all the way down. So that's the bottom left-hand corner. And then it's of width 8 and height 30. And then, of course, the color is brown. So that should look something like this. I've rendered this in grayscale because the green is interfering with the green screen that is behind me, and so everything gets zapped. So the top part of that little circle should be green. If you run this code on your own, you'll see it. And that little bottom part, that little rectangle, is brown. So I'm going to define a canvas, 400 by 400. I'm going to define a tree by calling the constructor at location 0, 0. So that the center of that circle of that one tree you can see is dead center of the canvas. And then I'm going to call the draw function associated with that tree, and then I'm going to render the canvas. Okay, simple class, nothing that we haven't seen before. And now let's imagine I want to build a forest. Okay, so something like what you see on the screen here. So what is this? Well, of course, it's just a bunch of trees rendered at random locations. And again, I've rendered this in grayscale so that it doesn't interfere. But the color of the background and the color of this middle part is slightly different. So when you run the code on your end, you'll see the color coding here. Now, notice one sort of clever thing that I've done here, if I can call it clever, is that the trees that are further back are all occluded by the trees that are in the front. So first of all, why did I do that? Well, it gives sort of a sense of depth. Things that are further back are more likely to be occluded than things that are in the front. And so by ordering them this way, that things higher in the visual field, that is, have a higher value of y here, are rendered as if they are occluded. Okay, so I did that just for a visual effect. It makes it look more three-dimensional. Now, how do I do that in practice? Well, remember that when you draw on a canvas, the last thing drawn has priority. So as you're drawing, you're occluding things. So that means when I draw this forest, I have to take the things that I want in the back, the things with the highest y value. I want to draw those first, and then things with the lowest negative or smallest y value should be drawn last. So I have to sort my trees. Okay, so I'm going to show you how to do that in a little bit, in addition to how to build a forest from a bunch of trees. So I'm going to take this out of the forest class just to make it a little bit less fussy, but you can imagine these are all going to be member functions of, for example, a forest class. All right, so let's see. I've got a create forest, a key that should look familiar. We're going to use a key function. We're going to use that to do the sorting that I just described to get that depth ordering, and then a draw forest, which of course we'll simply call the tree draw function. So let's do the create forest. All right, so this is going to take the number of trees you want, and so we have to make some decisions. How do we store all the trees? Now, obviously, these are all the same objects. We're going to shove them into a list. Lists are incredibly versatile. They're wonderful for these types of things. So I'm going to create an empty list called forest, And I'm now going to generate a bunch of trees at random locations. Let's not worry about the depth ordering just yet. And I'm going to shove them into the list. All right, let's go ahead and do it. So I want the x coordinate to be from -200 to 200. First of all, why that? The canvas is 400 by 400. Origin is at 0. That means I go from -200 to 200. So that's the x coordinate. It can be anywhere along this. The y coordinate I'm limiting to only -50 to 50, which is that little band that you see right here. So it doesn't go all the way to the top and all the way to the bottom. It's just a personal choice. You could have picked any values you wanted. So I pick a random x, a random y, and these are just integers because these are pixel values that I'm rendering at. And then I'm going to call the tree constructor with that location. That hands me back a tree object, and I'm going to append that to the forest. Now when I look at this, I realize now that I've done something that I didn't have to do. I could have just said forest, that's my list, dot append, that's the append function of a list, of call the constructor. That is, I don't need that variable. It's a temporary variable. I'm not using it anywhere. I may as well just take that constructor call and shove it into the append and bypass that one extra step, and I have one less line of code. Okay. Now, so at this point, and I'm going to do this, of course, num tree time. So for I in range num trees, we're going to iterate through num tree time. So when I called it here initially, I called it with 30. So it creates 30 objects and creates a single list called forest that has 30 objects in it, or num tree objects. Now, eventually I'm going to go and draw this thing, and so I want to order these things in the right order. I want the tree with the highest y value to be first, and the tree with the smallest y value to be last. And then when I render in order, the trees that are in the back are going to get rendered first, the trees in the front are going to get rendered last, and then we get that sort of nice little sort of perspective or depth ordering that you see here. So I'm going to call forest, what is that? That's a list, dot sort. Now, of course, you remember from the last lecture, I can't sort a list of objects without specifying on what. What information, alphanumeric information, do I want to sort on? So I'm going to sort on the function called key y. I'll show you that in a minute. And I want these now to go from highest to smallest value. So I'm going to do reverse equals true, which means it's going to sort from the highest to the smallest value as opposed to from the smallest to the highest. And then, of course, I'm going to return forest to whoever called me so that you hand back the list. The key y function that I use for sorting is simply returning the y parameter. Notice here that I've added an accessor function, which I didn't show you in the previous slide, which is just returning the y value. So all this does is return the y value. And again, I'm just doing this for that same reason that I don't like tapping into the data. If you want to access the data associated with an object, you should write these little helper or accessor functions. And so that's what that little function is there. It just hands the y coordinate back. The sort will sort on that, and everything else is taken care of. Okay, now let's look at the drawing. So the drawing has really three parts. The whole background here, which I'm rendering in blue, you can't see that here again because I've rendered this in grayscale because of the green screen. There's a middle green band where the trees live. That's green as if it's grass. And so that's just drawing two rectangles, and I'm using here a hex representation of a color. You can just search online for what these colors mean. So you can get beyond just the basic colors when you use these hexes. And again, if you run this on your Jupyter notebook, you'll see what the colors look like. And now all I have to do is render every tree because it's already been put in the right order for me because of that sorting. So for what is forest? It's a list. For tree and forest, tree will take on the value of every element in the list, not the index. There's no range here. I'm not indexing it from 0 to num trees. Tree will actually be the object that is stored in each element of the list forest. And since that's an object, I can simply call its draw member function, so that will draw the tree at the appropriate position, and then I'm done. Define the canvas, create the forest, draw the forest, which calls the function I just defined, and then render the final drawing. Okay, so here again you see this interplay between, well, actually between this object, which again I haven't wrapped up in a whole class just to make the code a little bit more compact, and of course again lists of objects. And notice again here is sort of the magic where I'm taking advantage of the fact that object, that class already told me how to do things, and so I don't have to reinvent the wheel. Okay, so now we have one more lecture left in the category of objects and classes, and we're going to do a much more complex class with a few more moving parts, and I'm also going to introduce some new concepts in there, just basic Python algorithmic concepts. So when we come back, we are going to code up the game of life. And you've probably seen this before, and if you haven't, go ahead and Google it. It's just a simple game where you model cells in a grid, and we're going to do that by building a couple of objects, a couple of classes, and then doing the animation to be able to basically play the game of life. So when we come back, we'll pick that up and do a little bit more on objects and classes. I'll see you then.